All right, so we're talking about the packet. We are covering the last half of the packet. We're going to start at problem 28. And the question is about range. Mr. V, would you read me 28, please? Yes, please. All right, so if I had to graph that to get the range, I'd want to graph it. I would want to see, what does this kind of look like? Would you agree that that would be the exact same thing as this? I said negative x squared plus 10, which would tell me it's a parabola that's upside down and moved up 10. So as soon as I know what the picture is, it's a parabola, it's upside down, it's been moved up 10. Do you get now that the range will be a lot easier? The range is the how low to how high, okay? And how low does it go? It goes down here forever. So it goes from negative infinity to how high would this ever go? It tops out right there at 10. So I can tell my range by looking at the picture. If you didn't have a picture, it would be very hard to do. Okay, so you got to kind of know what the pictures look like. It'll never get to negative infinity, but it will get to 10. So there's my range. Negative infinity to 10. All right. That's 28A. And other ones, if I were you, make a little sketch. Say it looks like maybe it looks like this when you're done with your sketch. It's a B that's been shifted to the right, moved up, or whatever. Then you can say the range would be from here's the lowest it would be to, it keeps going up forever, so from, like, let's say 1 to infinity. All right, that's how you do ranges. And the next kind, after number 28, anybody have a question about 29 or 30 or anything? Okay, question about 30. Everybody turn to number 30. If you look at number 30 and you're like, huh, that's child's play, go ahead and work on a different problem. But I want you to look each time at the problem and see if you need help or not. Okay, would you read me number 30? Increasing? All right, so, and decreasing? Just increasing. All right, so if the picture looked kind of like this, I'd say, oh, it was increasing from 0 to infinity. I would say that kind of a deal. So now, how about we graph number 30? Would you read me the problem? Minus 1? Minus 1? Is it in parentheses or is it like I just did? All right, so then, I need to verify that because that's not a normal parent one. All right. Okay. I'm going to answer this one like it was this. I think this is what the teacher meant to do. Because that's the volcano function, and we know what that does. This still seems like it's the volcano function because it's got the x squared in the bottom. But then this part right here, I can't tell which way it's been moved because it's not on the inside. So this is kind of, I think it's a messed up question, to be honest. So I'm gonna change the question, and you could change it to this if you want to. X minus 1 quantity squared. So that's the volcano function, except it's been shifted 1 to the right, and oh, it's a negative on top, and it's been flipped. All right, so here's just the volcano function like normal, and then here's shifted to the right, and then here would be flipped. All right, so now that it's the black function, what do they want to know about it? They ask, when is it increasing? Well, this one's decreasing in this little zone, so it would be increasing in this little zone. So the increasing part is this green part right here. And that would be from, we're talking about x's here, from 1 to infinity, but it can't be 1 because the volcano function doesn't actually exist. So it would be from 1 to infinity, or it's not 1, it'll never get to infinity. It would be increasing. Okay? And if I'm wrong on that, I'm sorry, I just can't think of how you would graph this thing the way it is written originally. So if the key is different, it could be that there's some way to graph that I just come up with off the top of my head. I thought I would have put it like this and made it a volcano function. That's what I think. Okay, so the moral of the story, you graph the thing. And when you're done graphing the thing, you find out where it's going up. And then you see the x values from here to, I guess, it never stops. So you draw a line like this. So from 1 to infinity. All right. Next kind, number 29. Any questions on 29 or 30 or 31? Feel free, if we're doing one and you totally get it, then skip ahead a little bit and then you can... Yes. Extrema. Extrema are just the high spots and low spots. So if I had a graph like this, that's an extrema and that's an extrema. It's either a high or a low spot. Maxes or mins, another way to say it. Those are extremes. Okay. Any other ones you want to ask about? 30, 31, 29, anything in there? Yes. Anybody had something before 32? Was yours before 32? Okay, 32A, would you read it? Like that? All right. I hope that... Is the squared on the outside on this one? It's just 3 over 1 plus x squared, like that? We're doing the same thing again. I can't picture what the graph of that should look like. If it had parentheses around the whole bottom, then it would be the volcano function. Does anybody have the key for it? Did they? Oh, I don't have to make a picture for this one. Oh, okay. All right, it can be written like this then if I don't need another picture. All right, odd, even, or needed. We haven't talked about that in a long time. So let's talk about what odd and even ones look like. Do you remember what an odd function has one kind of symmetry, and even function has another? This one's an even function. It's got symmetry right down the middle. Like it's the same on both sides of the y-axis. Okay, that's the even kind of function. How about odd kinds of functions? Remember what kind of symmetry they have? What's that? Is that the odd kind of symmetry? It is. Okay, so everything that this one has for a point, let's say it has the point 1, comma 1. This one would have the point -1, -1. Any point here would match up with another point over here. Okay, but if you tell something's odd or even algebraically, that's different than from a picture. Do you remember the odd rule and the even rule? Here's the odd rule. If you are, how were you right near, which problem number is this? 32, right near number 32, I would write down the odd rule and the even rule. The odd rule is this thing. F of negative x is equal to negative f of x. And you say to yourself, oh, that's odd, there's 2 negatives. Do you remember that? And then there's the even rule. The even rule is you go f of negative x starts the exact same way. Then there's only one way to do it. We've already had a negative on the outside. We've got a negative on the outside. What's the last option? Just plain f of x. Doesn't have any negative at all. All right. So then, what this is saying is, if I test it and I stick in negative x in my function, that it should come out exactly the same as if I put a negative in front of a function. So now, on this actual thing that you told me before, and unfortunately I have to ask you, like that? Okay, good. If I was going to tell you if that's odd or even, I would take that function and I would stick in a negative x into it. And do you remember me telling which is smarter to test for, odd or even? It really doesn't matter too much. How about this one? It's the easier one to test for. Even. So I might as well test to see if it's even. How about this? You see how it's got a squared in it? If it's going to be something, it's most likely going to be even. So I test for even in this case. And if it's not even, though, then you have to quick test to see if it's positive. Because just because it's not even doesn't mean it's neither. If I test it's not even, it's not automatically odd. It could be a neither. There's really 3 tests. You test the odd, test the even, and then if it's neither one of those, it's neither. All right, so I'm going to test even. So even test is this, f of negative x equals to be f of x. That's even. And then I'm going to test it. I'm going to stick in negative x in here, right there. So it's going to be 3 over 1 plus negative x squared. And then the 3 is still a 3, the 1 is still a 1. Negative x squared, isn't that just going to become plain x squared? Yes, it is. And then plain old f of x. I start with the original, which is this one. 3 over 1 plus x squared. Is this equal to this? And I just proved it's even. Remember the even and the odd rule? I think that was worth asking. It's a good question, because we haven't talked about those in a long time. It took me a second to solve it. Okay, so that's 32. That should also cover like A, B, C, and D and stuff. How about 33? Any questions on 33? You want to see it done? I'll gladly do it. I'm going to be think of it this way. I'm going to be answering questions all the way to the end of the hour. So I may as well be doing ones you need help with, right? So don't like just say, I don't want to be embarrassed and give a suggestion for a question, because I'm going to be telling somebody else an answer to their question. So you might as well get your questions answered. If there's any of these you want help, check. Okay, so 32, 33, 34, anything in there. But I also don't want to ramble on if you don't need help on it. Yes? 33b, would you read it, please? And what is the directions? What am I supposed to do with this? Find the vertex. All right, the vertex is the point that is at the bottom of the V. So if this is a V-shaped graph, they just want to know where's that point right there. And the vertex is really easy to find. First of all, you could do this 2 ways. I'm going to show you the easy way. The easy way is to just kind of think what the picture looks like. It's a V shape that's been moved. Where did it get moved? Left 4 and down 2. Do you get that makes this point right here -4, -2? And then there's another way, which is to just say, oh, I remember that's where the vertex goes. You know, if this had been a parabola, it'd be like a squared here, but there isn't. So it's an absolute value. It's this comma this, except this always negative from what or the opposite from what it seems like it is. So there we go. Same answer. But you could have just got it from looking at the picture, or the equation, or you could look at the picture to get it. So just faster is if you recognize it, if you're like this. 3x squared plus, actually we need the numbers, x plus 3 squared minus 7. You should be able to just go, oh, -3, -7. It might have been a little weird because that was an absolute value instead of a parenthesis, but it's the same idea. Vertex is found here and here. Okay, next one, yes. Okay, you want me to do an odd one. All right, I know this one will be odd. I guarantee you that one's odd, okay, because it's x cubed. How would I test the question of with the odd rule? It is f of -x equals -f of x. Oh, that's odd. There's 2 negatives in it. So if I test one that's negative, and I stick in a negative, I go like this, x cubed, except I put in -x, -x. When I take -x times -x times -x, it'll be -x cubed. Do you get that? And now the other side is just the opposite of f of x. I got to put a negative, and then I put a parenthesis and drop in f of x. It's right here. So I go like this. And I just ask myself, does that come out the same? And it does. Because x cubed and then make it negative is -x cubed. That's equal to that. So it came out. All right? So I think the key to the odd rule is this negative right here. Because otherwise it's exactly the same as even. So that negative right there, you just stick a negative and a parenthesis and you drop in the function. You distribute the negative out. See what happens. Yes. Number 34A. And by the way, if we jump over one and you want to go back to 33 because we never talked about it or whatever, that's okay. But I'd rather keep moving with ones you really care about. So 34A. All right, so I better look at the picture for 34A. Just give me a second to find it. All right, so that's a weird looking graph, but it's not exactly a parabola. So it's going down like this, and then you'd think it'd be a parabola, but then it's like going, it's kind of like it's bent a little bit. Okay, now there's two ways we could go with this. If that was supposed to be a parabola, it would be really close to having even symmetry. But the point is it odd, even, or neither? It still wouldn't even be even because this vertex is off a little bit. So to be even symmetry, it would have to be like this. So it's so messed up that it can't be odd or even. So that would be neither. Because remember, they got symmetry if they're odd or if they're even. All right. So the one that's probably the hardest to read there is C, and C's graph goes like this. And has that got odd or even symmetry? Do you remember me doing this deal where you go like, okay, this point right here, if I reflect it through that point up to there, see how it's got a point that goes with it? And if I take this spot here and I reflect it through that spot, do I got a point over here that goes with it? Yes, I do. So this has got special kind of symmetry, so it's odd. Take this point here and I reflect it through there, it should come out down here, and it goes. That's got symmetry that's going through the origin. It's a double flip, or you could think of it as point symmetry. The symmetry through the point, 0, 0, here, 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 here. So anyway, that has odd symmetry. Moving on, does anybody want 35 or 36? Asymptotes, should we talk about Bob and bigger on bottom, bigger on top, same on both? Seeing lots of knots, all right. So if it's bigger on bottom, that means it's like this. That's Bob, that's bigger on bottom. And there's three kinds you got to watch out for. Bigger on bottom, and those are y equals 0 plus whatever's on the outside. Nothing on the outside of this. If it's been like a plus 6, that would mean the function moved up 6. So, of course, this couldn't be 0 anymore, up 6. So you've got to watch out for if they've ever added something on the outside. In this class, we almost never do that. I just want to add that on. It's usually, Bob's are just zeros. But sometimes they can add something on the outside. Okay, next thing is it's bigger on top. If it's a bot, that would be like this. Let's just do this so you don't think everything cancels. X to the fourth over x to the third plus 1. That's bigger on the top. The rule for bots? There's no bots. Like robots, except no bots. And that means there's no asymptotes. And then the last option is it could be the same on both. And that's like if this was a 14 and this was a 14. They're the same degree. And those are a ratio. Y equals a ratio of the lead coefficients. In this case, there's a 1 here and a 1 here, so it would be y equals 1 over 1. Y equals 1. So it's bigger on bottom, bigger on top, and same on both. Those are for horizontal asymptotes. Bob will tell you about the horizontals. The verticals are the denominator. The vertical asymptotes are what makes the bottom 0. Okay, and in this case, it would be like x equals 4 and x equals negative 4 are the vertical asymptotes. Yes. What? Oh, if nothing makes 0. Good question. So if it's like this, there's no way to make the denominator 0, so there are no asymptotes. That would be for the vertical asymptote. Say none. For horizontals, it's bigger on the bottom, so it'd be y equals 0. Or sorry. Yeah. Horizontals are y equals 0. So this one would have a y equals 0, but there'd be no x's. No x equals asymptote. Because it's bigger on the bottom. No, wait. Come on. Bigger on the bottom has an asymptote. Sorry. Bigger on the bottom. This would have an asymptote. That's different than a... Oh, wait a minute. Okay, this is bigger on the bottom, so it's this kind of an asymptote. It has a horizontal, H-O-R-I-C. It's got a horizontal asymptote. What it doesn't have is a vertical asymptote. No vertical asymptote, because there's no x equals things that would crash. Okay, more questions? Yes. Which problem number? 35A. Okay. The question says, find horizontal and verticals of this. All right, so the horizontals are the ones Bob will tell you. Is this bigger on bottom, bigger on top, or something? And therefore, this one y equals ratio of number 1, so y equals 1. How about the x equals 3? Those are the vertical asymptotes. Vertical asymptotes make x things. Horizontal asymptotes, those are y things. All right, so what is the vertical here? What would crash this if I put in 1? So that crashing makes an asymptote. Yep. No, that's you. What you're thinking of as a domain. This is an asymptote, is a line. So there's a line in this graph right there. There's a line right there. No, that's vertical, sorry. Horizontal line. There's a horizontal line at 1. That's this one right here. There's a vertical line at 1. That. So that's the blue one, the other one's the red one. Now, what you were asking about is something different. If just change to the right answer. This is the right answer. What were you asking about? If that's a domain question. That's if they ask you the domain of this. The domain of that function would be all reals except x cannot be 1. That's the domain. Yes. Yes, there often are 2 vertical or 2 horizontal asymptotes. Wait, no. Horizontals, bigger on bottom, bigger on top, similar both things. Those only are 1, but you can have 2 vertical asymptotes. Yes. Whatever makes the bottom of the function crash. Yes. And any holes. Now, this one doesn't have a hole, but I'll show you one that would. Let's say we had this over this. This kind has a hole where there's something on the top and the bottom that are the same, and they would cancel each other out. That kind makes a hole. And the hole would be at the number that makes it crash, which would be -2. It's the thing that would make it 0 over 0. And so that kind has a hole at -2, comma, and if you wanted to know the other part of the hole, you actually have to take the -2, stick it back in the function that's left. The function that's left is now y equals 1 over x minus 3, because this cancels. So I take this function and I stick in the -2 in there. I stick in the -2 right there. I have 1 over -2 minus 3 would be 1 over -5. There's my complete hole. The first part is just what would make this thing crash and give you 0 on the top and the bottom. And the other part is take that number, stick it in the equation, and you figure out that. Holes is on the test case. Finding the second part of the hole, maybe not. But at least you'd have to know that there was a hole at x equals -2. But I know you learned this even last year in HA, so it would be fair game for this test. To find the other part of the hole. The only complicated part is that part. So it's like if I show you, you should automatically be able to say, oh yeah, that factors. So x plus 3 at x minus 3, there should go. And that makes a hole there at 3. The only hard part is, where's the other part of the hole? 3, comma, and the other part of the hole is, you just take the 3, stick it back in the equation, and I'd have y equals 1 over x plus 3, and then I'd put in that 3. 3 goes right there, and I'd have y equals 1 over 3. Okay, yes. Yep, 36B. Find the domain of the function's inverse. Oh, tricky. All right, so first of all, I got to know its domain and range of the parent. 36b. Here's the parent, the one it comes from. X plus 3 over x minus 2. If they want the domain and range of the inverse, you want to find the domain and range of the original one and then just flip-flop them. Find the domain and range of this one, and then we'll just flip-flop them to get the inverse's domain and range of domain of the inverse. A little negative 1 implies inverse. Okay, so domain and range of this guy, its domain is everything works except x cannot be 2. And that will become the range of its inverse. See, the domain of the regular one is the range of the inverse. So this will become all reals except, now notice a range cannot be x. Changing that to y. Now the range of this original, that's tough because I got to draw a picture for it. So I don't think they'd ask you that. Didn't they just ask on number 36 to find the domain? I guess, you know what, we do have to figure out the range of this one to figure out the domain of that one. So to figure out the range of this one, so that I can know what its domain of the inverse would be, I need to find the range of this. All right, let me see the graph of that. Oh, I know. I remember. I don't need to know what the graph looks like. It's just about the asymptotes. Remember how ranges get interrupted by a line like this? Ranges from low to high, right? So I just need to know what the asymptote was on this. So this is a horizontal asymptote. So then I go ask Bob what the answer is, and it's same on both. So it's y equals 1. Asymptote. If there's an asymptote at y equals 1, do you get the range then? It's going to get blocked by that 1 to be able to go there. So then my range is all real numbers except y cannot be 1 because that was a horizontal asymptote. That means the range now has told me the domain of the inverse. I just do this exact same thing except change it to x. All reals except x cannot be 1. Wow. Hardcore. So you get the main point, which is that the domain and range of the parent one just get flip-flopped. You get that. That's the main thing. That'll answer like half your questions. Then when you need to find a range of one where you don't know what the picture looks like, you got to use the Bob rules. So if you want a range, you can use Bob rules to find out where it won't work. And that'll tell you like, oh, there's an asymptote. And so you'd say, oh, okay, everything works except that asymptote. So if the asymptote is -2, you'd say all real numbers except y can't be -2. All right, that was a tricky one. Nice curveball. What else you got? And that's good. You noticed a hard problem and you're asking me for help with it. That's awesome. It's G. 35F. Okay. Okay, x squared minus 4 over x squared minus 3x minus 10. And this was number 35F, if I got the right one. Okay, then you factor the top and you go x plus 2, x minus 2 over factoring x and x. And how do I make a 10? A 5 and a 2 is probably going to work. 5 and a 2. And then one of them needs to be negative so I can make this negative. So I'm going to go with a -5 and a +2, and check it outside and inside, make -3x, which is what I want. Okay, great. Okay, is what I want to say there. Okay, there is my answer. Is there a hole? Yes, because this and this cancel. That makes a hole. And I know you're thinking, but there's another 2 thing there. That's okay, there's still a hole. This makes a hole because there's one exact thing on the bottom and the top that cancel each other out. So there is a hole in there. Okay, and if something's a hole, it can't also be an asymptote. So the vertical asymptote on this would have been 5, and the hole would have been where x was -2. That was 35 F. What else do you want to see? We got 12 more minutes. I can show you a lot more math in 12 minutes. Anything in 36? Domain of the function's inverse. Those were like ones where you'd find the range of the parent one, and that tells you the domain of the inverse. Ni. 37. Okay. Use interval notation to describe the set of real numbers. All they're asking is, how do you write this with parentheses? Remember that? So how would I write this? How would I write x is greater than negative 3? From negative 3 to infinity. Can it be negative 3? No, because it doesn't have an or equals, so I put a parenthesis. If this had a or equals, I'd put a bracket. So it's just basically writing it with the parentheses. That's what interval notation. I think the rest of those should be easy for 37. Just write them with sets of parentheses. Alright, how about 38, 39? Anything in there? Yes, ma'am. 38A. Alright, so it says the line through the points negative 4, 5 and 4, 3. This is 38A. Alright. First off, I'm going to look for a equation that you should know. You guys remember that equation? So that equation is used where I know 2 points. This point and this point. And I put those points into this equation. Now, could you find the slope a different way? Yes, but I kind of actually like finding the slope this way. I could pick this to be x, and this to be y, and this to be x1, and this to be y1. Maybe you could go either way. You could switch around the ones on the first point if you wanted. It doesn't matter. So now I'm going to put in x is negative 4. Y is 5. Y is 5. X1 is 4. Y is 3. Now I've plugged everything in. 5 minus 3 equals m times negative 4 minus 4. And now I can solve for m, and I'll know my slope. Alright, so then I go 5 minus 3 is 3 equals m times negative 8. And I divide by negative 8, so it's 2 divided by negative 8, which is also known as negative 1. I just found my slope. But that's probably not what they wanted. They wanted the equation of the line. Alright? At least I know the slope now. So now you start the problem back over again, except you know that the slope's negative 1/4. And here's the equation, the red one. And I know now what m is. So now I'm going to do that work. I figured out that m is negative 1/4. So I'm going to put a negative 1/4 right here. And now I just have to put in one of my 2 points. Put in either one you want. It doesn't matter. I'd probably pick this one because the numbers are positive. So I put in x is 4, y is 3. Y minus 3 equals negative 1/4. X minus there's an equation that has the point in it and the slope in it. In the back. 47. Did you have something before 47? 39A. Let's do 39A. 47 is big jump. So, got something before 39A? Yes, you may. Are there food with them? No, not. All right. So back to what was the earlier of the two? 39A. All right, everybody look at 39A and see if that's something you need help with. It's got a vertex of 1, 3. That's the vertex. And it's got another point of 0, 5. So picture this. It's got a vertex at over 1 and up 3 is like there. And over 0 and up 5 is like there. Is another point on my parabola. So my parabola probably looks like that. All right, so now I want the equation for it. You gotta know the formula. Once again, if you were writing yourself a list of formulas to know for the final, this one would be on there. A times x minus h squared plus k. Does that ring a bell? And now you're going to take the vertex and put it here and here. And you're going to take your other point and put it here and here. So now here we go. the x and the y of this other point are going to be x is 0 and y is 5. And the vertex is at 1, comma 3. I'm going to rewrite it. 5a times 0 minus 1 squared plus 3. All I did was stick in everything except a. Now I'm going to solve for a. 5 equals a times 0 minus 1 is negative 1. Negative 1 squared is 1. Plus 3. Now I'm going to subtract 3 from both sides. 2 equals a. Do I get something else, or am I right? You think it's 2? All right, so if a is 2, now I start the problem over again. Go back up to this one. Here's my equation again, except now I know what a is. A is 2. So now I'm going to stick in any other point. No, I usually put in the vertex. That one right there goes in. And so I put the x of it goes in here, and the y of it goes in here. Final answer, y equals 2, parentheses, x minus 1 squared plus 3. There we go. Okay, is it before number 47? All right, what's the next one? Yep. All right, when they give you this and this, they just gave you 2 points. Hold on a second. So, back to this problem. They have given me 2 points. Negative 3 comma negative 1. And they've given me 6 comma 7. And if they just tell me 2 points, it must be a straight line. So I'd use this formula. Y minus y sub 1 times x minus x sub 1. And find the slope first. Once you found the slope, you put in either point you wanted. Probably that one. Stick it in here and here. Does that answer that question well enough? All right. So let's move on to anything before 47. We know we're going to get to 47 eventually here. Anything between now and 47 is fair game. Is this? There it is. Good. Okay, let's get to the next question. Can't take this flu thing too seriously. It's one way to say that you should take it seriously. Do you know that there's 10 times as many people? 10 times, 10 to 1 ratio in Chicago that got the flu this year than last year. 10 times. That's a lot more people. So many people in Chicago with flu that there's 2 hospitals that are turning away ambulances. Ambulances drive up with people in them, and they'd say, go to some other hospital. Can you imagine how little they are if you move in? So, it's pretty bad. Yes. 40B. Yes. Would you read me number 40B? 6ax cubed minus. All right, and what do we want to know about this thing? So basically, find the end behavior on this thing means if this is a positive number right here and here, so in other words, we're not messing with that. It's really just going to be like this. The end behavior is told by the lead coefficient. This one's the lead coefficient. It's the biggest degree. So this number right here is the actual coefficient. It's positive. That instantly tells me that the right side of this graph should be going up. Remember that? If the lead number is positive, the right side is going up. If this number here, the front number on the biggest degree term is positive, the right side's going up. And then since this is an odd one, the sides must be going opposite directions. So if this side's going up, this side must be going down. So this end behavior would be on the left side's going down and the right side's going up. Now that I know that, I can actually write a limit for it. Because it asked me to write the limit notation to write the end behavior for the function. I'm just going to write one of them because they take a long time to write. Limit of the function as x approaches, I'm going to do the right, that would be as x approaches infinity. And if I'm doing the right end, what it means is this, so it's, if you wanted the left end, you just change this to a negative infinity, now you're on the left, and I look at the left and it's down there, so I just change it to negative. So first get a picture of what the graph looks like, then you can make your limit. Yes? Because these a's were positive, I have no problems. If these a's had been negative, then that's going to change this to be a negative 6. You know what I'm saying? And this would change that degree right, or that negative right there. If this a was negative, that would make this a positive. But that one really wouldn't even matter because it's squared. And the squared term is less than the cubed term, so this is the only one that really matters, because it's the biggest degree. So if this had been negative here, then all of a sudden your lead coefficient would become negative. Okay, whew, lots to know. We're covered a lot right now, and if this went too fast, remember you can always go back and review the video later. Next one, before 47. All right, we got to do 47 next. Still want to know 47, or did you figure it out by now? All right, so 47. A square side S is inscribed in a circle. Inscribed means it's inside. So inscribed square looks like that. You get that. And its side is S. So they're all S's. Square. I'm drawing my picture. Remember how I generally say draw the picture and then try to figure out a formula and stick the stuff from the picture in the formula? All right, so my next thing, could I label this, and this is a key moment. If you just draw it across this way, you'll be kind of missing the point. Could I go across this way and say that that's a radius, right? But I could actually figure out how long that is in terms of S. That's what the problem is going to boil down to. So, in labeling this question, I got to figure out how long is this little piece from here to here. Well, basically, I've got a triangle right here. I'll focus in on it by using red. And on that triangle, I could say that this side squared plus the other side squared should equal this mystery length. I'm going to call L. Actually, I should call it D for diameter. Squared. And if I want to know how long that is, first I got to know how long that D is. So I'm going to solve this to say it's the square root of S squared plus S squared, which is D. That's the diameter. That's the whole thing. Like from here to here is this. So if I really want the radius, I could say that the radius is half of that. So this is a true statement, but I could also say the radius would be the same exact thing, S squared plus S squared over that, divided by 2. That would be the radius. Now, I did all the hard work. Now we just got to finish it up. Right, the area of the circle is a function of S. All right, so if I want the area of the circle, area is pi r squared. And remember how I said we did all the hard work by figuring out r? There it is. Now I can just plug it in right there. So I got area is pi. R turns out to be this guy. Just for a second, please. S squared of S squared plus S squared over 2. Okay. What? If you wanted to do it where if you wanted to say R and R, that's okay. You can do that. That's maybe the way the teacher did it. And it's still going to come out the same answer. When it's all simplified, it should come out the same answer. Okay, yes. Okay, hold on just a second. If you're wondering why it was on the 4th, because you see how it's this 2 here, and this is getting squared, that's going to make your 4th. The 4th. No, S squared plus S squared could be 2S squared. Couldn't be the 4th. And it is about time to go. All right, so, yes, it would be still under the square root. I didn't even finish that. Anyway, I wasn't trying to simplify all out. I was just answering questions like, is s squared plus s squared equals s to the fourth. It's not. It's 2s squared. All right. Have a great day. I'll look forward to seeing you on the day of the final. You can always come in for help on Tuesday morning if you want to. 8 to 10 a.m.